Welcome back to topic 46 for Algebra 2, Graphing Radical Functions. In part 1, we're going to learn how to graph the parent function of both the square root and the cube root. Let's start off with the square root. The parent function for a square root is y equals the square root of x. And remember, this can also be written as y equals x to the 1/2 in exponential form. Now, in order to graph this, let's start by filling in the table. If we plug in -1 for x, what is the square root of -1? Well, it actually gives us an error. And that's because we can't take the square root of a negative number, at least not when dealing with the real number system. It deals with imaginary numbers. However, if we plug in the square root of 0, that gives us 0. Square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Now that we have these points, we can plot them on our table. Or they're in our table, we can plot them on our graph. Notice how my graph only deals with positive numbers. There are no negatives to be found. And also looking at the graph, we can identify the domain and range. Remember, the domain deals with all of the x values and the range deals with all of the y values. So if we look at our graph, what is the smallest possible x value that we see? Well, it starts at 0. And since this is a point on our graph, this is finite. So we can use a bracket here. The largest possible x value that we have, well, our graph would keep going and going and going off to the right, closer and closer and closer to infinity. Since infinity is not finite, it's infinite, we use parentheses. Now the range, the smallest possible y value that we have here, is also 0. And the largest possible y value, if you were to take your graph and zoom out, would be positive infinity. What we have here, this is called interval notation. Moving on to the cube root, the parent function of cube root is y equals the cube root of x. Again, this can be rewritten as y equals x to the 1/3. Now if we plug in values here, let's try with the first one. What is the cube root of -8? So what number times itself again gets us -8? That's -2. And since there's an odd number of negatives, that's why we get -8 as our answer. -2 times -2 times -2. The cube root of -1 is -1. The cube root of 0 is 0. Cube root of +1 is 1. And the cube root of 8 is 2. So here, note that we can take the cube root of a negative. Now that we have our table, let's plot on our graph. So over -8 down 2, over -1 down 1, over 0 up 0, over 1 up 1, over 8 up 2. So here we kind of have an S-graph. Actually, if we were to take this graph and rotate it about counterclockwise a quarter of a turn, we'd note that it actually looks really similar to a cubic graph. So that makes sense, doesn't it? The cube root looks somewhat similar to a cubic graph. Also, similarly with our square root, it kind of looks like the half of a parabola on its side. So that's kind of where things are originated from. Now looking at this, we can identify our domain and range. Domain, again, is the smallest possible x value to the largest possible x value, which in this case is negative infinity to positive infinity. And if we look at our y values, if we kept zooming out and zooming out, our y value would get closer and closer to negative infinity, and it would go to positive infinity. Even though on our graph here, it looks like it's kind of hitting a certain point, if we kept zooming out and out and out, we would get closer and closer from negative infinity to positive infinity. And that was part 1 of topic 46 for Algebra 2, graphing radical functions. Thank you for watching.